Where's bell work? We've got an equation that we got to solve, just like we did in the last unit, because we are starting a new unit today, but I do not see any distribution or combining like terms necessary here, so I'm just gonna move straight into principles of equality. And the first thing I would want to do with the principle of equality is to be able to drop this 3x to isolate it so that it's by itself, which means that plus 5, I need to zero out so it goes away. So to do that, I'm going to subtract 5 there. But if I do it to one side, I'll have to do it the other side as well. And 5 minus 5 does equal 0, just as we planned. But then by subtracting 5 on the right side as well, I got 19 minus 5, which is 14. The last thing I need from this is to make the coefficient of x a 1. So I have a 1x, not 3 x's. And to make a 3 a 1, I'm just going to divide it by itself. So 3 divided by 3 is 1, but I'd have to do 14 divided by 3 as well. The decimal is going to be very big, so I'm going to just make it a fraction as 14 thirds. 3 times 14 thirds, that'd be 14, and then 14 plus 5 is 19. So that's true, which tells us that if you replace the x in the original equation with 14 thirds, you get a true statement out of the equation, which tells us this is the solution, which we pretty much expected, but we made sure. Here's our objective for the day. First objective for Unit 8, I can identify, compare, and simplify ratios and rates. So take 30 seconds and copy that down, please. Okay, some of this vocabulary may be kind of new, ratios and rates. I really hope that it's more of a review for you guys, but if it's new for you guys, that's okay. We'll go over the vocabulary and then we can understand what this means in terms of math. But hopefully you remember what rates and ratios are. So a ratio is just a comparison of two values, right? So two numbers, you're gonna look at two numbers, compare them, that's all. Which usually means that we're looking at how many times one value goes into another. So sometimes it doesn't go into another value, a whole value. Maybe it's like only half of a value or a fourth of something like that, okay? But when you do see rates, you're looking at division, which we're going to be showing as fractions. So it is possible as a ratio, you may see the word 2 between the two numbers. Sometimes just a colon between the two numbers. You could even technically put a division sign between the two numbers, which is just kind of a colon with a line between, right? And there's different ways to show division, but for the most part, we're going to be showing these as fractions. So the fraction, of course, in the top here, you're going to have your numerator. And then in the bottom, you're going to have your denominator. So these are like boxes that you can fill in with numbers, and that would be a rate, okay, or a ratio. But it is a comparison of the two values. Rates are ratios with labels. Rates are just ratios with labels, okay? So in the fraction like this, you may see the numbers, but you'll see the numbers with labels. Generally speaking, one of the numbers is going to be like dollars, perhaps, like this one. And then usually the other one is in some form of time, maybe hours. Now, it's not always a comparison of dollars per hours, but it's something like this. As long as there's some kind of labels. In fact, sometimes you could say, well, maybe it's like gallons per hour, something like this. Miles per hour, something like that, okay? It doesn't really matter what we're comparing. Sometimes it's even the same thing. You can compare gallons to gallons if you're looking at two different cars or something like that, okay? But that's what a rate is. But then we also have this, and I think this is where it gets kind of new for us, is where we're looking at a unit rate here. So a unit rate is where one of the values is a 1. And it doesn't matter if it's the top number or the bottom number in this. It could be either one, just as long as one of the values is a 1, okay? Now, generally speaking, for us, we like for the denominator to be a 1. So a unit rate, it'll usually be like a per unit. Okay, so I mean, there'd be a first label there too, so it could be like dollars or like we see there, gallons, or it could be even like hours or something like that. Dollars, gallons, or hours per some unit, some type of unit. Okay. Now, when we say unit, we're talking about some kind of label there. We just don't know what the label is, which was why we call it a unit. Okay. Now, if they give us a rate and neither one of the values is a 1, which is going to be common in the assignment, then we will have to force the value to become a 1, which we're going to be doing. And we can do that pretty well with pretty much what we've seen already with our principles of equality. Now, here we have a comparison of two values, right? 16 and 40. And remember, when we see this word 2 right here, it really indicates that we're looking at division, which then tells us that we're going to be making this a fraction, okay? Fraction. Okay, so I'm gonna put out my fraction line. There's my fraction line. And as long as you remember that the top number here is the numerator and the bottom is the denominator, then this should go pretty well because it always goes in this order. The top number is the numerator. That's better. And the bottom number is the denominator. Okay, so all I got to do is fill in my fraction with the top number, which is the numerator. I can see that's the first number, 16. And then the second number is the denominator, that's the 40. Now, if this were not simplifiable, then I'd be pretty good at this point. But I know that it can be simplified because 16 and 40 are both even. Not only are they even, so that means they're divisible by 2, but I know that they're multiples of 4 as well. But also, if you continue to think about this, you know that they're actually divisible by 8. So I can find a new fraction here. It'll be worth the same. It has the same value, but I'm going to simplify this because 16 and 40, I can divide these both by 8. So this will give me a new fraction. 16 divided by 8 is 2. And in the denominator, 40 divided by 8 is 5. Now, if we would look, just check to see if this is simplifiable, but it's not, which means that this is our final answer. Now, is there an easier way to do this? Yes, just like we've seen from the fractions unit, and pretty much after that is you could have just typed 16 over 40 with the N over D button on the calculator and then found that this would have reduced to 2/5. It's just as long as you remember that the first number here in the ratio is the numerator, second number is the denominator, then it fits. Okay, now what makes this a ratio, not a rate? It's because there is no labels. If there were labels on this, then we would quickly call it a rate instead of a ratio, and we could compare two quantities. So here we go. We got Elijah earned $925 at his job. When he worked for 40 hours, what did he earn in 1 hour? Okay, so just starting off, let's start with our rate now because we're comparing two labeled values. I'm going to start with the dollars here. And generally speaking, if I see dollars, I like to put them in the numerator. And usually when we're comparing dollars, we usually are comparing it with some form of time. Now, are we always going to be comparing with time? No. But on this one, I see that we are comparing this with hours. So that'll be my denominator label, okay? Well, why is this important? It's because for any future fractions that I make from this rate that I'm comparing, I need the labels to stay where they are. So where I have dollars in the numerator, I need to keep the dollars in the numerator. And where I have hours in the denominator, I just need to keep that in the denominator. See that? Okay, and in fact, these fractions that we're going to be writing are actually going to be equivalent, which means they have exactly the same value. They're just going to be shown a little different. So what are the values that we're comparing? Well, for the dollars, I see it's $925. And since I have the label there for dollars in the numerator, I'll put my $925 in the numerator. Now, you can put the decimal there if you'd like. But technically speaking, you wouldn't necessarily have to because it's just a double zero. Then I can compare the hours, which shows as 40 hours. So that will be, we already know the label there is in the denominator. So I just have to put the numerical value with it, which is 40 in this case. So this is the rate. And if you were to read this rate, it would read $925 for 40 hours. You could also say it as $925 per 40 hours, but we don't usually use the word per unless we're looking at a unit rate. Okay, but per and for, in this case, both of those indicate that we're looking at some form of division, which again is why we're using the fraction line here. That's the division sign. So the question states, though, how much did Elijah earn in 1 hour? So we know in the final rate we want there to be 1 hour. And we also know that 1 hour indicates that we're looking for a unit rate. Okay? Because unit rates is where one of the values is 1. And in this case, it's 1 hour. So this fraction, we're going to simplify this fraction. Let's just look at the 40. I need to change the 40 into a 1. How would we do that? We take the 40 and divide it by itself. 40 divided by 40 That would give us the 1 in the denominator. So we know for fractions, if you do something to either the numerator or denominator, you have to do to the other one. So where I divided 40 by 40, I must also take 925 and divide it by 40 to get my new dollar value. So I got 925 divided by 40. I'm just putting this in the calculator, and it shows me 23.125. Now, if this was not money, then I would probably keep this decimal as is. But I know money can only go into the hundredths place value, so I can't have something in the thousandths place value. So that tells me that I need to round this. So I'm targeting this hundredths place value. I look to the right. Is it 5 or more? Yes. So I need to add 1 to the 2, which is going to change this into 0.13. Now, since we rounded, this is actually more of an estimation, but that's okay. And on Canvas, by the way, when you write this in, you'll probably only need to write this number in. You don't need any of the labels. Generally speaking, it will have the labels for you. Okay. But again, the way we would communicate this final rate here is $23.13 per hour. And again, the per hour thing here, this indicates per 1 hour. So yeah, we could expand that a little bit more. And we could say, well, $23.13 for every 1 hour. Yeah, both of these are communicating exactly the same thing. They're just set different, that's it. Mike bought 20 video games for 88 bucks. How much does each game cost? Well, we are looking at a comparison of two values here, video games and dollars. So I'm going to set this up with a fraction. Now, I said earlier that I usually like to put dollars in the numerator, but on this one, I'm just going to kind of purposely put it in the denominator to show you that it really doesn't matter, okay? In fact, I'll end up doing this twice just to demonstrate it. But I know I'm comparing dollars here with the $88, but the other comparison is video games. Now, you could write video games if you want while you're doing this by hand, but that's more writing than I want to do, so I'm just going to put games. And then you can know that it's video games. Okay, which means that my future fraction, because we're pretty much always going to be writing two fractions, I'm still comparing the same two labels, games and dollars. Okay, so I have my two labels here. So what did it give us? The information that was given was 20 video games, and right now I have that in the numerator, 20 games for $88. So again, you could write the decimal out here. You can just write it like this if you'd like. It doesn't really matter. It's 88. For this one, though, since we've already seen one like that, I'm just going to get rid of the decimal there. Okay, so $88, 20 games for 88 bucks. But we see in the question here that it wants to know how much each game costs. That's really asking how much for one game, which tells us we're looking at the unit rate. But this time, like I said before, we usually like the 1 to be in the denominator, but this, just the way that we have this set up, since we're looking for one game, that's going to be in the numerator, and that's okay. So I need a fraction that's going to have the same value here as this fraction does here. Okay, so again, we look at some of our scale factors and how we simplify these fractions, because I'm going to take 20 games and reduce it to one game, right? So I'm going to take that 20 and divide it by 20 to make 1. But we know from fractions, whatever you do to one, either the numerator or denominator, you got to do to the other one. So I got to take the 88 and divide it by 2 as well. So in my calculator, 20. I take 88 and divide it by 20, not 2, but 20. And what do I get? 4.4. Okay, now since this is dollars, kind of like that last one where we had to round, this one, it's only showing the tenths place value, but we usually have 2 decimal places for money to show the pennies. So I'm going to put a 0 there in the ones in the hundredths place value. So once again, this is our unit rate right here. And it's okay that the unit is in the numerator. So you could say, well, I'd say each game costs $4.40. something like this. But again, on Canvas, I believe you'd only have to type in the 440. So there's one way to do it. Now, what this means, there's a couple ways to do this, right? So for this one, I'm gonna take my original fraction here, but this time I'm gonna do the same comparison. It's just that the dollar is gonna be the numerator, and then the games will be in the denominator here. Okay. So dollars and games, which means that I should have the same exact ratio over here as well, right? Dollars and games. And so what do we start out with? Well, we knew it's $88 for 20 games. But we know again, well, to make 20 games one game, because that's what it says up there, I got to take the 20 and divide it by 20 to get the 1. So I take 88 and divide it by 20. You see how we get the same exact values here? $4.40 for one game. It's just backwards. Instead of each game costing $4.40, it's still equivalent. It's just said a little bit different. Let me say it's $4.40 per game. Or for one game. Again, it doesn't really matter how you say that. It's the same thing. But again, on Canvas, whether you do it this way that we did first time or the second way, it will end up being the same $4.40 like this. So you'll never be required to do it twice, but I'm showing you that it doesn't matter how you set up the rate with games in the numerator or games in the denominator, you'll get the same answer either way. So for this problem, Anne earned $1,669.12 at her job when she worked for 32 hours. What was her hourly wage in dollars per hour? This one is good. I think this is a good one for you guys to practice on. Take a minute, try this one out, then we'll go over it, okay? All right, so hopefully you guys finished that, but right here, we know the two things we're comparing in this. So I'm gonna set up my fraction line because I know I'm looking at a rate. Because right here it asks for hourly wage, which tells us it's a rate, and that may be the first time we've seen that, but I know I'm comparing dollars and hours. Okay, now before I place my labels on this one, I know in the end, it tells me it wants the rate in dollars per hour. Okay, and the per is the divide sign right here, which tells us that when we look at dollars right there, that needs to be the numerator for us, okay? Because the per word right here is kind of like the to word for a ratio, because it's the fraction, or it's the division sign, okay? So the first number is always your numerator, the second one there, the hours, this needs to be our denominator. Okay? Now, whether you misplace these or not, it's important for you to understand right here that it's asking per hour. What's her hourly wage in dollars per hour? So it's really asking how much Anne makes every 1 hour. Again, this is a unit rate because we're looking for every 1 hour. And in fact, in the past, some students have just kind of snuck in a little 1 right there. And if that helps you out, then do it, okay? So this tells us where each label should be. In the numerator, I have dollars, and then in the denominator, hours. And this will be true for both of the fraction, dollars and hours. It's just in the end, I know that I need this to be a unit rate. So my unit rate there, 1 hour, that'll be my final fraction, okay? But then what do we start with? Well, it tells us it's $1,669.12. So that's my numerator, 1,000. How do I know that's my numerator? It's because it's the dollars, and I've already placed the labels in here, so I'm just filling in the numbers. Well, it was $1,669.12 for 32 hours, and we know the hours is the denominator, so there's my 32 right there, okay? So this sets up my rate, and I need to change this so that it's not 32 hours. I need to change it down into 1 hour by dividing it by 32. This will change that into 1 hour. It's just if I do that to the denominator, I'll need to make sure to do that to the numerator as well. So in my calculator, $1,669.12 divided by 32, enter. And this shows me that it looks like Anne will make $52.16 every 1 hour. Okay, but again, this is the unit rate. Now let's say that by chance you had mixed these up. Maybe you put hours in the numerator and dollars in the denominator. You'll still notice that all that happens is these numbers flip. As long as you understand that we're looking for 1 hour, so you'd have a 1 hour here, you'll still get $52.60 per hour. Okay, it's just, it'll be kind of reversed. And again, it may even communicate, it may sound like it communicates different because it's every hour she'll make $52.60. Whereas right here, it's saying she'll make $52.16 every hour. Okay, but they still have the same value there. Dom's car used 12 gallons to travel 258 miles. At what rate does the car use gas in miles per gallon? So this one's nice because just like that last problem, we see the word per, which indicates that's where our fraction or division line will be. And yep, pretty much all these we're going to be comparing as fractions, all of our rates. Not only that, but then it tells us, remember to put miles. The first number is miles, first quantity is miles. That's going to be our numerator. Miles in the numerator, and then gallons will be in our denominator. Now again, if you get these flipped, it won't matter as long as you understand what the unit rate is on this one. And it is asking for a unit rate because this is asking in miles per gallon. So we are looking for miles per 1 gallon. And again, I think while we're getting used to this, it may benefit you to write that in as per 1 gallon, okay? Because again, this is a unit rate right here. How do we know it's a unit rate? Because it's for every 1 gallon. So my other fraction is going to have it'll have exactly the same labels in exactly the same position, okay? It's just now I know that I'm looking for every 1 gallon, so I can put a 1 there for my gallon. Well, what other values were given to us? It says it was 12 gallons, and even though for my fraction it's in the denominator, it came first, it doesn't matter. We already know that gallons, the way that we have it set up, will have to go into the denominator. Well, that was traveling 258 miles. That's how much gas Dom's car used. So this is our setup, 258 miles for 12 gallons of gas. But we want to know, using this rate, how many miles will Dom get every 1 gallon? So again, we say, well, 12, and we make a 12-1, just divide it by itself, okay? It's just if you do it to the denominator here, you have to do it to the numerator as well. So 258 divided by 12, that gives me 21.5. 21.5 miles every gallon. And again, this is unit rate because we have the 1 gallon. This is it. Miles per gallon, is that showing? Yeah, miles per gallon. And if you had it flipped, it'd just be 1 gallon for every 21.5 miles. But it will mean exactly the same thing. It's just, that's it. All right, for this last example, a grocery store sells a bag of 10 oranges for $5.20. What is the unit cost? Now this one is not being so clear about the unit rate on this one, right? But it is a unit rate because it's asking for a unit cost. So hopefully that becomes pretty clear just with the way that this is worded, okay? But it's really asking how much does every unit cost? And the reason why this is important is because what are the units in this one? Well, we know it's not cost because it's already asking about cost. So the units on this one is actually the oranges. And you could even say, well, it's the per 1 orange cost. Or the cost per 1 orange, however you want to word that, okay? In any case, this helps us to set up our fractions right here because I know we're looking for every 1 orange. That tells me that I'm going to put oranges into the denominator. And then my dollars, that's going to be in the numerator, okay? So this is the way that my rates set up. And that's the way my unit rate will set up. It's just that in the end, we only want 1 orange, okay? So it tells us it was 10 oranges, so that's my denominator, so that's the way I have my label in there. 10 oranges for $5.20. So the dollars, $5.20. And, well, we want to change this into dollars per 1 orange, so you'd have to take the 10 and, well, divide it by 10 to get the 1 orange. And so you'll take the $5.20 and divide it by 10. That'll give us 52 cents here, okay? So it looks like for every orange, it's gonna cost about 52 cents, or 52 cents exactly. But this right here, that's our unit rate, okay? Now, I think some of you have noticed, if the way you set this up, and this is kind of why on purpose, I like to have my unit in the denominator, my 1 unit, my ones, in the denominator, because if you just take these two values, whatever two values they are, just divide them, it will give you the unit rate, okay? As long as you have it set up so that the 1 is in the denominator, as we've seen. Because look, 5.2 divided by 10, that's the fraction. It's just, I'm kind of showing it in a different way. So in the beginning, as long as you understand this, and I'm not saying everyone does because it's kind of new, if you just taken the 520 and divided it by 10, you would have gotten the answer at 52 cents. As long as you understand it's 52 cents per orange. That's the main thing, okay? Now there's our objective. I can identify, compare, and simplify ratios and rates, which really just means that you can identify, compare, and simplify fractions. It's just when they're rates, they're just fractions with labels, that's it. Ratios are fractions as well, they're just shown usually as a different way, with a 2 between the numbers or a colon between the numbers, but a divide sign will work also.
Double good.